This is Srikanth, Assistant Professor of IEEE Department in Institute of Aeronautical Engineering. In this session, we are going to discuss about introduction to choppers and classification of choppers in the power electronics subject. And now, first of all, what is a chopper? Chopper is a circuit which converts a DC supply into a variable DC supply. A DC supply is nothing but which is having a constant magnitude of voltage and current. So this DC voltage will be converted into a pulsating DC by using this chopper circuit. And in this chopper circuit, the pulsating will be of a square wave. We are going to generate the square wave output. A chopper which is used to convert, a fixed DC into a variable DC, and these choppers are going to use in electric cars and conversion of wind energy and solar energy and DC motor regulators, because wherever we require a DC voltage variation in that particular applications, we are going to use the choppers in the power systems. And coming to the chopper is nothing but it is like a switch. In this, it is like a switch control. When the chopper is operating, we need to have some control strategies for the chopper. That is, control strategies are nothing but control methods for the chopper. In the control methods are of two types, because the chopper is a switch which is going to operate based on the on time and off time of the chopper circuit. In place of chopper, we can use the thyristor as a chopper, and these the control strategies of chopper are: one is time ratio control and another is current limit control. In the time ratio control, here the chopper is controlled with a duty ratio, where duty ratio is defined as the ratio of on time to the time period of the chopper. On time to the time period of the chopper. And coming to the time ratio control, in the time ratio control, we are having two types of time ratio control, where delta can be changed to, that is, delta is nothing but the duty ratio, that is T on by T. Delta is T on by T. In this, delta can be modified, delta, or it can also taken as alpha, where alpha is also called as duty ratio, or delta is also called as a duty ratio, which is known as T on by T. So here we can vary the alpha duty ratio either by varying T or by varying the T on. In this, either we can vary the alpha value by varying T or T on. Any one we can vary by keeping other parameter as constant. So here, in the first waveform, which is shown here we are keeping, this is a pulse, this is also called as pulse width modulation technique. So in this, we are keeping T as constant. When T is constant, T on can be varied by keeping T constant. T on can be varied in order to vary the duty ratio of the chopper. So here, duty ratio is varied by varying the T on. In these two waveforms, T on is different for the first waveform. T on is different, and the second waveform T on value is different. So when the T on value increases, the alpha value also increases. When T on value increases, alpha value also increases. This is the way we can go with the constant. This is also called as constant frequency. So, constant frequency control strategy for the choppers. And the second one is variable frequency control method. In this, it is also called as frequency modulation control. In this, we are going to keep T on as constant, and we are going to vary the T varies. So here in this waveform, T value here, the first waveform T value is having some high value which is shown clearly, but the T on value is not varying in the two waveforms. Only T value is varying from first waveform to second waveform. So the duty ratio is nothing but T on by T. We are keeping T on constant and we are varying the T. When T varies, automatically frequency varies because frequency is inversely proportional to T. So the duty ratio varies. That is the reason why it is also called as variable frequency system. Variable frequency system. Now we'll move on to the second classification of control strategy of chopper, that is current limit control. In the current limit control, we are going to take the consideration of output current into our switching sequence of chopper. Okay, once the output current is reached the minimum value, we are going to switch on the chopper, and when the chopper is switched on, output current increases. When the output current increases and it will reach the maximum value, we are going to set the limits for I0 minimum and I0 maximum. Once it reaches the maximum value, immediately the chopper is going to turn off. Once the chopper is turned off, again the current discharges because the load will be charging and discharging mode, because we are having the inductive loads. In our day-to-day life or industries. Everywhere will be having the inductive loads. So the charging and discharging will take place. So once it reaches again the minimum current, again we are going to switch on the chopper. Once the chopper is on, we are going to get the output voltage, that is VDC, or whatever the input voltage which we have given, and the same voltage will appear across the load. And once the chopper is off, no output voltage, that is zero voltage, will be having the zero voltage. And then after again, we'll be having the output voltage of VDC. This is the way we are going to get. Once the current reaches the minimum value, the chopper is going to be turned on. Once the chopper is on, we are going to get the output voltage. And once the chopper is off, once the current reaches the maximum, immediately the chopper is going to be turned off. Once the chopper is off, the output voltage is 0. This is the way we are going to control the chopper circuit by keeping the minimum and maximum currents into the consideration. And now we'll move on to the classification of choppers. The choppers are classified into based on the different parameters. The choppers are of different types, and depending on the output voltage of the choppers are classified as step up chopper, step down chopper, step up or down chopper. So here, based on the output voltage available, we are getting, based on that, the choppers are classified into three types with with the circuit, when the output voltage is more than the input voltage, then when the output voltage is more than the input voltage, then that type of chopper is called step up chopper. When the output voltage is less than the input voltage, then that chopper is called step down chopper. And the step up or down chopper, the two possibilities we are going to get with a single circuit. Two possibilities we are going to get with a single circuit. And depending on the direction of the output current and voltage, the choppers are classified into 5 types. Those are Class A, Class B, Class C, Class D, Class E choppers. In this, Class A and Class B are one quadrant choppers which are going to produce the output voltage and current only in one quadrant, and Class C and Class D choppers are going to produce the output voltage and current in two quadrant modes, and Class C chopper we are going to get all 4 quadrant operations in the Class C chopper. And first we'll go with the step down chopper. This is the chopper circuit which we are having here, a Vs DC voltage which we are going to apply to a chopper, and chopper which is shown like a switch, and within the dotted box is a chopper, and this chopper, in place of switch we can use any thyristor or MOSFET based on the requirement or based on the voltage ratings availability or based on the voltage requirements of the load. We are going to use the different switches, different power semiconductor devices as a switch. And a freewheeling diode is placed, a freewheeling diode here placed in parallel to the load, a freewheeling diode which is going to give the continuous current during the non-operation of the chopper, continuous current to the load during the non-operation of the chopper. And here the inductor is placed in order to charge. This inductor is going to, which is shown like a load which is having the inductive load. And here the load is connected across the, in series with the inductor, and which is in parallel with the freewheeling diode. Once the chopper is on, it acts like a short circuit. Once the chopper is on, freewheeling diode will experience a positive voltage. Freewheeling diode will experience a positive voltage across the cathode and negative voltage across the anode. So once the diode experiences a positive voltage across the cathode and negative voltage across the anode, so that freewheeling diode will be in reverse bias condition. So once the freewheeling diode is in reverse bias condition, the current starts flowing from Vs, chopper, inductor, load, and Vs minus. This is the current direction in the circuit which is shown in the figure. So once the current is flowing from Vs positive 2 and Vs negative through the load, here the output voltage will be equals to, because when we assume the inductor is a lossless device, there is no voltage drop across the inductor. So the positive output voltage is connected to the input positive voltage, and negative of output voltage is connected to negative of input voltage. So the output voltage will be equals to V0 is equals to Vs. So here we are getting, when the chopper is on, we are getting the output voltage which is same as the input voltage. I'll show you the waveform. Here, these are the output voltages. This is the input voltage Vs, a straight line which is having a constant magnitude. Once the chopper is on, this is the on time of the chopper. Once the chopper is on, the output voltage we are going to have, which is same as the input voltage. And this is what we got. Once the chopper is on in the circuit, which is inductor, current is flowing through the inductor. Inductor is going to charge its energy. So the inductor is going to charge. Once the inductor is charging, the output current is increasing. Mode. It is under charging mode. And once the chopper is off, after certain time, whenever we want to off the chopper, when the chopper is off, it is acting like a open circuit. No current is flowing from input to the output. And whatever the charged inductor will reverses its polarities. Once the inductor reverses its polarities, the positive of inductor is connected to the positive of anode of freewheeling diode. Positive of inductor voltage is connected to the anode of freewheeling diode. So once the positive supply is connected to the diode anode, immediately the freewheeling diode will get forward bias. Once the freewheeling diode is forward biased, the current will be flowing. Load is having a continuous current through the freewheeling diode with the energy stored in the inductor. And once the freewheeling diode is short circuited, when it is forward biased, freewheeling diode is going to act like a short circuit. Once the freewheeling diode is acting like a short circuit, what is the output voltage? Output voltage across the short circuit. Output voltage across the short circuit is 0. So in this mode, when the chopper is off, we are going to get the output voltage is equals to 0. Again here, when the chopper is off, output voltage we are getting 0, and inductor current is discharging in this mode. So inductor current is discharging, which is reducing in the exponential form. Inductor is going to store the energy in the form of electromagnetic field, and that energy will be in the exponential form we are going to get. So exponentially increases when the inductor is charging, exponentially decreases when it is under discharging mode. We need to derive the output voltage equation. So average output voltage is equals to average output voltage V naught average is equals to 1 by time period integration 0 to t a function of f of t dt. Here 1 by t, here t is the time period, and we are having function only available only during the on time of the chopper. So t on, and the function we are having it as Vs as the function dt. Integration of constant with respect to dt is 1 by t. Integration of constant is Vs into t, where the limits are from 0 to t on, which is equals to 1 by t into Vs into t on minus 0, which is equals to Vs into t on by t, which is equals to t on by t can be written as delta into Vs or alpha into Vs. Always alpha value is equals to t on by t, where alpha value is equals to t on by t. So always T on value will be less than T. Always T on value is less than T. So alpha value will be always less than 1. So the V naught average is equals to alpha into Vs, where alpha value is always less than 1. So V naught average value is also always less than Vs. That is the reason why it is called step down chopper. It is called step down chopper. Now we'll move on to step up chopper. In this step up chopper, inductor is placed first, which is in series with the source voltage. Inductor is placed in series with the source voltage, and the chopper is connected in parallel to the load. And here the freewheeling diode is connected and load is connected. So here, once the chopper is on, it acts like a short circuit. And here we are having two paths for the current. Always the supply will be the supply from the source. We are getting the current, and this current is divided into two. And even here, diode is also forward bias because positive of input voltage is connected to the anode of the diode. Okay, so two paths are there, but the current is going to choose only a path where we are having zero resistance. Whenever we are having two paths with zero resistance and with some resistance, always the current will choose a path where it is having zero resistance path. Always the current will choose a path which is having a zero resistance. So when the chopper is on, the current will be flowing from Vs plus inductor, chopper, and Vs minus inductance, voltage plus inductor, chopper, and Vs minus. This is the path where the current is going to flow. So here, once the chopper is on, there is a short circuit across the load. Here the output voltage is 0. Here the output voltage is 0. And inductor is charging in this particular direction. Inductor is charging with the first terminal as positive and the second terminal as negative. This is the inductor voltage. And here when the chopper is on, inductor is charging and we are getting the output voltage is 0. Once the chopper is off, it acts like an open circuit. Once immediately the switch is opened, immediately inductor will reverses its polarities. Now the both voltage, the source input voltage and inductor are in the same direction. Hence the output voltage will be equals to, here the chopper is open circuited, the positive of output voltage is connected to positive of inductor voltage, which is in series with the source voltage. Here the output voltage will be equals to Vs plus VL. Output voltage will be equals to Vs plus VL. This is the way we are going to get the output voltage when the chopper is off. Here we are getting more voltage. Here the inductor voltage is almost equals to the source voltage at the discharging point. This is the output voltage of the chopper once the chopper is off condition. I will show you the waveforms now. Once the chopper is on, we got output voltage as 0. Once the chopper is off, we got output voltage as Vs plus VL. Here, once the chopper is on, Once the chopper is on, output voltage is 0. Once the chopper is off, we are getting the output voltage is Vs plus Vl. This is the way we are getting the output voltage. Once the chopper is on, it is under charging mode, so the current will be increasing. Once the chopper is off, the current will be decreasing mode. Current will be decreasing mode. And again, once the chopper is on, the current will be increasing, charging and discharging positions of the current. And here the output current will be available only during the chopper off condition itself, because once the chopper is on, no current is flowing, because current will choose a path where it is having a zero resistance. So these are the current output current waveform. These are the output voltage and output current waveforms for the step up chopper. Now we need to derive the output voltage equation. Here we are going to take the energy input to the inductor and energy output from the inductor. Based on that, we are going to write the output voltage equation. So here, when the chopper is on, the energy input to the inductor only, once the chopper is on, only the source voltage will appear across, only a source voltage will appear across the inductor. So energy input, energy is nothing but power into time, that is Vi into time. Vi is the power because it is a DC supply, power into time. The energy input is equals to Vs into, we are having only one current, that is I0 current, into, this is during the chopper on condition. This is during the chopper on condition. And energy output from the energy output from the inductor, once the chopper is off, immediately energy output will be here. The terminal of the inductor voltage is going to reverse its polarity, that is VL is going to reverse its polarity. So inductor voltage will be equals to V0 minus Vs, because this terminal is positive, because we are taking the inductor voltage, this terminal is positive, so V0 minus Vs is the voltage across the inductor into I0 into T on. Under steady state condition, the energy input is equals to energy output, because we are assuming that inductor is a lossless device. So energy input is equals to energy output. Energy input is equals to energy output, which is equals to Vs into I0 into T on is equals to V0 minus Vs into I0 into T off. This is during the period off condition. So I0, both currents are same, both are cancel. Vs into T on, which is equals to V0 into T off plus minus Vs into T off. Here Vs into T on plus T off is equals to V0, where V0 is equals to Vs into T by T off. We can write it as T off is equals to T minus T on. We can write T off is equals to T minus T on. Vs into T by T minus T on. If we divide both with both the numerator and denominator with T, you will get Vs into 1 minus T on by T which is equals to Vs by 1 minus alpha or 1 minus delta. So here the output voltage V naught average we are getting Vs by 1 minus alpha. And as we have discussed, always the alpha value is less than 1. When the alpha value is less than 1, always output voltage will be greater than Vs voltage. Output voltage will be always greater than Vs with this equation. We can also say, with this equation also, we can say that this is we are going to get the output voltage is greater than the input voltage. Now we'll move on to step upper down chopper. In this chopper, the inductor is placed in parallel with the load. Inductor is placed in parallel with the load. Once the chopper is on, the free diode is going to act like a open circuit, because diode cathode is connected to the positive of input voltage. So the diode will be under reverse bias condition. Once the diode is under reverse bias condition, once the chopper is on, the supply will be going through the Vs plus inductor and Vs minus. Vs plus inductor and Vs minus. Here, when the chopper is on, inductor is going to under charging mode with this particular direction. Once the inductor is charged, inductor is going to charge in this particular direction. This is the VL sign convention. This is during the chopper on condition. Once the chopper is off, immediately inductor will reverses its polarities. No supply, no current is coming from the input side. So the inductor reverses its polarities once the chopper is off condition. So inductor positive voltage, which is connected to the inductor reverses its polarities when the chopper is off condition. Inductor reverses its polarities. Inductor voltage reverses its polarities. Once the inductor voltage reverses its polarities, diode anode experiences a positive voltage. When the diode anode experiences a positive voltage, it acts like a forward bias, or it acts like a short circuit. The diode gets forward bias. Once the diode is forward bias, the current is flowing in the reverse direction. So in this chopper, we are going to get current in the reverse direction during the chopper off condition. So here we are going to get the output voltages, which is here output voltage will be, we are going to decide based on the availability of inductor voltage across which is connected in parallel with the load. So here we are going to decide the output voltage equation based on the energy input to the inductor and based on the energy output from the inductor. So energy input from the inductor is Vs into I naught into when the chopper is on. Energy input to the inductor is only during the chopper on condition. Energy output from the inductor is V naught into I naught into T off condition. So under steady state condition, we are assuming that inductor is a lossless device. Energy input is equals to energy output. That is equals to Vs into I naught into T on is equals to V naught into I naught into T off. So these two gets cancelled. Vs into T on is equals to V naught into T off. So here Vs into T on is equals to Vs in V naught into T off. Vs into T on is equals to V naught into T off. So output voltage is equals to Vs into T on by T off, which is equals to Vs into, if we divide with T both the numerator and denominator, T on by T into T minus, I am writing T off as T minus T on by T, which is equals to Vs into alpha by 1 minus alpha. This is the output voltage equation of the step up or down chopper. In this, 0 is less than, alpha is less than 0.5. It acts like step down chopper. 0.5 is less than, alpha is less than 1. It acts like step up chopper. And this is for today's session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.